Hello, ladies and gentlemen. Today we're going to be starting our next unit, Unit 8 of the year. We are simplifying rational expressions. For this, you're going to need your notes, something to write with, and of course a calculator would be handy as we go about basically breaking apart expressions here and figuring out how to simplify things that are written as fractions, okay? So for this, our objective or our real focus for the next few days and actually the next few weeks, we'll be learning how to simplify rational expressions accurately. So what does it mean to simplify these things that are written as fractions? How do we go about that? What skills are involved? So first thing I need you to get in your notes are some basic definitions. Rational expressions. What is this? So a rational expression basically is a fraction. And if you think about it, the word ratio is actually inside there. Ratio is a fraction, like 2 over 3, okay? So the fact that the word ratio is in there is telling me that I'm dealing with something that can be written as a fraction. It can contain, however, more than just numbers. They can contain numbers, variables, terms, these things called terms, and polynomials themselves. So most of our prior knowledge includes dealing with them as if they were numbers, like 1/2 plus 1/3. But also now we're going to expand into the whole variable idea, terms that make up polynomials. So all these different things can take place in the terms terms of a rational expression. So how to simplify them? You're going to need to understand some skills that we've already learned, like how to simplify a fraction, how to correctly cancel things, as people like to call it, okay? So how to correctly simplify, and especially how to factor. So this idea of factoring comes back again, and this time we're going to use it to help simplify rational expressions. So let's remember back to when you first learned how to simplify fractions, or even recently in a review of simplifying fractions. We can take a look at how it is that simplifying comes about. So like 10 over 12, 10 over 12, if I was going to simplify that fraction, what would that simplify to make? Well, be careful. This idea of simplifying a fraction means that we're going to divide the same thing on the top and the bottom out of that fraction. So 10 and 12 both divide by the number 2. And then we end up with 5 over 6. The incorrect way to take a look at canceling or simplifying is this idea that you can take 10 and break it apart into terms. 7 plus 3 and 9 plus 3. While that's true, 7 plus 3 does make 10 and 9 plus 3 is the same as 12. These are two pieces that are added together, okay? And that means that we cannot simplify like this and say my final answer is 7/9. Because we know that 10/12 is not the same thing as 7/9. We know it has to equal 5/6. So be careful to understand this big idea. You do not ever cancel terms. Those are things that are being added and subtracted together. Like the 3 and the 7 were terms being added together. But we can cancel factors. Okay, let's take a look at this other example that I did with the dividing by 2 here. That's what you're familiar with. How does that work? Well, this is what's really happening. Oops, back. This is what's really happening. Is we break apart or we factor the 10 into factors of 5 times 2, and 12 is 6 times 2. We have factored the 10 and factored the 12. And by doing that now, we can divide the top and bottom both by 2. That's why dividing by 2 works on top and bottom here. And that's how that 5/6 comes about. So this idea, again, we cannot cancel or simplify those terms away, but we can do that to the factors within. So let's take a look at some examples of how we do this when those problems become a little bit more complicated. This is the first one you need to get in your notes. This is 40x plus 20 divided by 10x plus 30. Now, like we just got done saying, you cannot take a look at this and go, ooh, 40 and 10, they can simplify. The 40x and the 10x are terms of a polynomial. That's a polynomial there. This is a polynomial here. We cannot just simplify term with term. The only thing we can do is simplify factors. So what would we have to do to this guy? we'd have to factor him. So let's take a look just at the top right here. What can we do to factor a 40x plus 20? Well, we can take out a greatest common factor. What number divides out of 40 and 20? The number 20 will. And if I divide it out of those two terms, I end up with 2x plus 1. So 20 times 2x plus 1 is the same thing as this over here. However, it's factored now. Now let's do that same thing on the bottom. What can I do to the 10x plus 30? I can factor out a greatest common factor of 10. So it becomes 10 times x plus 3. Now what can I simplify? Now that it's factored, I can simplify factors with factors. Now I can take a look at that and say 20 over 10 is the same thing as 2 over 1. So it becomes 2. The 2x plus 1 has to stay together, and 1x plus 3 has to stay together. So that is the simplified version of that beginning initial rational expression. Okay, we have to factor it, and then we can work to simplify it. Let's take a look at another example. We're going to simplify this guy. So on the top, take a look at him. Remember, we cannot simplify term with term. Sometimes people want to do this. No, that's 2x squared is a term. We cannot do that unless we take a look at his factors, okay? So let's factor the top. Let's take out a greatest common factor again. How about a 2 and an x can divide out of those two things? That leaves you with an x plus 4. If I divide this by 2x, and if I divide this by 2x, divide the greatest common factor out, and this is what we have left. Now on the bottom is just 12x. There's no other terms. So let's just leave him as 12x and take a look at how this helped us. The x plus 4 we can't touch, but these guys right here, we can simplify that now because they're factors. They're multiplying to make something, okay? So 2x divided by 12x. Let's simplify that. That's 1 over 6 for the 2 over the 12, and the x over the x would factor away or divide away, so we don't have to worry about that. And then we have x plus 4. Okay, so this is the simplified answer for my rational expression. Let's take a look at this one. Just got a little bit more complicated. On the top and on the bottom, we need to factor the numerator and the denominator of this fraction, okay? So let's take a look very beginning at the very top of this fraction. What can we do to break this guy apart or to factor him? Let's do that greatest common factor bit again, okay? So we're going to take out a 2 and an x. And then when I do that, I leave myself with an x plus 5. 2x times x plus 5 is the same thing as 2x squared plus 10x. Now on the bottom, this has 3 terms. Can I take out a greatest common factor? No. So what do I do when I have 3 terms? The AC method. So let's take a times c and we get 15. What multiplies to make 15? That's the a times the c, and adds to make 16. How about 15 and 1? Then we put them in the 4 squares, ladies and gentlemen. AC method, 3x squared, 15x, 1x, and a 5. Pulling out greatest common factor from each row and column. So the factors of the bottom, the two things that multiply to make the 3x squared plus 16x plus 5, the factors happen to be x plus 5 and 3x plus 1. Now, how does this simplify? Remember at the beginning, we said you can only simplify or only cancel out factors. Okay, we're looking for dividing the top and the bottom by the same thing. So we have to look for common factors that they have. Notice that both of them have an x plus 5 as a factor. That means I can simplify those two pieces. Okay, so what is my final answer? 2x left on the top, and in the denominator, 3x plus 1. And you can put those parentheses around it, and you don't really have to because there's nothing else. So this is my final simplified answer. Notice we factored and then we simplified those factors, okay? And let's take a look at this one. How about x squared minus 49 over the top of numerator over denominator 2x squared minus 4x minus 70. All right, so here we go. Let's factor top, bottom, numerator, denominator. Let's figure it out. How do we factor x squared minus 49? 49 is a perfect square. So this factors into x plus 7 and x minus 7. That's a difference of perfect squares. On the bottom, the denominator, what are we going to do? Well, we have 3 terms. They don't have a greatest common factor. Oh, wait, they do. I can divide them both. Oh, actually, all of them by 2. Let's do that. Let's take out a 2. Yes, that helps me a little bit. Now I can go ahead and do the AC method with what I have left. A times C, what multiplies to make negative 35 and adds to make negative 2? Negative 7 and 5 does that. Okay, here we go. Going to continue my factoring. Placing those terms in our 4 squares here for the AC method. Going to factor out greatest common factor from each row and column. So notice how that trinomial splits apart now. Remember that 2 we took out initially? Keep him there. He's still there. Then my other factors become x minus 7 and x plus 5. Now that everything's been factored, now I can look to start canceling or simplifying, okay? These guys go, and now what I have left is an x plus 7 over 2 times x plus 5. Okay, simplify the numerator and denominator by factoring first, and then you can go ahead and look to cancel those factors. Thank you very much for taking good notes, ladies and gentlemen. We'll get some more practice on this in days to come.